Alright, starting lesson 9.3b, geometric sequences and series. Now it seems like there's a lot going on here with this formula, but actually once you break it down, it's quite simple to work out. Alright, so for example, when it says find the sum, we have our sigma notation here once again. And I'm starting off the first value of 1, and I go to 7, so there's 7 terms total. Alright, and I could take this formula and replace the sigma notation. So what is my first term? Well, if you just plug 1 in here, you get 2 to the 0th power, which is 1. Then I have 1 minus r. What's r in this case? Well, r is essentially this number. Right? It's whatever you're raising to the n minus 1 power. So that's going to be 2, and to the nth power, n is 7 in this case, over 1 minus r, which is 2. Alright, so I end up with negative 127 over negative 1, which is 127. Alright, it's as simple as that once you know how to interpret the formula. Alright, find the sum. Notice here that we're not starting off at 1. We're starting off at 0. But in order to apply the formula correctly, I need to start off at 1. So we're going to restructure this expression here. I'm going to start off at 1. So if I start off at 1, there still needs to be 21 terms. All right, if I go from 1 to 20, that's 20 terms. But if I go from 0 to 20, that's 21 terms. So I'm going to move this one up 1. I'm also going to move this one up 1. So I'm still working through the same amount of terms. Now here I have 10. Then I have 1/5, and then with the n, I'm going to subtract 1 from that. Okay, because if you go back here, we would plug in 0, and so my first term, I'm taking this to the 0th power. So for my first term, I still want to be taking this to the 0th power. So when I plug this in, I have 1 minus 1, that's 0. All right, so essentially, these are now the same expression. They just look a little different. Alright, so working this out, what do I get? So I have the first term, which would be what? I have 0, 1/5 to the 0th power, which is 1, times 10. So my first term is 10. Then I have 1 minus r. r is this value here, which is 1/5. And it's to the 21st power. And it's over 1 minus r, which is 1/5. Okay, so work that out, and it's equal to. Okay, now for find the sum of an infinite geometric sequence. Okay, the formula is a little different. It's actually much more simple. Find each sum. Okay, so we're going from 0 to infinity. We have 5 for our first term. A sub 1 is 5, and r is 1/2. So using the formula, then I have 5 over 1 minus 1/2. I get 5 over 1/2, which is 10. Done. All right, for the next one, I have, it's telling you it's an infinite geometric sequence. I have a sub 1, which is 5. And r, which is 0.5 over 5, which equals 0.1, which is 1/10. Okay, so now I have the sum, which is equal to a sub 1, which is 5, over 1 minus 0.1. So 5 over 0.9. Which is, well, I don't like having decimals in my fraction, so I'll move that over 1, and I'll move that over 1. So it gives me 50 over 9. So that's my sum, 50 over 9. You could also write it as a mixed fraction. Done. Alright, so there's some formulas that look a bit complicated, but once you understand what's going on, it's really simple to work out. If you have any questions, please make sure to ask. Begin the assignment at the bottom of the page.